Guys, can you hear me?
Yes.
So, regarding the teachers, we are discussing about the data collection and the data information we have to need to make the proper layout. Basically, when we are making a layout, we have to require some data or some information, some vendor data, or some like calculations. Then we will decide what are the capacity and the other things uh, need and make the layouts. So I'm just sharing my screen. So basically, can you see the screen?
Yes, I see.
Today lecture is about the layout formation basic data. From the tomorrow class, we will start our case study on the SketchUp, how we will make the proper layout. I will give all of you assignment at the end of this class, and you have to respond me in the tomorrow class. Then I will start the next working. So basically, we will work and we will find the data in the today class. So basically, when we have to make a layout, when we have to make a layout, we have to make a thesis report. We have to need some data from the client side, from the vendor sides, and from the internal communications of the interdiscipline coordinations. So, so today we are discussing what data we require to complete the layout, complete the PVC's report, to proceed the other work of the solar project. So the first of all is option is the DC capacity. When we are working on the layouts, we need the DC capacity. So the DC capacity we get from different sources. Like on the large scale projects, we talk about the large scale projects, we get the DC capacity from the client side. They clearly give us the instruction that how the DC capacity, amount of the value of the DC capacity you have to achieve. The specified locations, specified area. But on the small scale project, when we are doing like the survey of the rooftop of the ground mounting systems, client give us space area. It is the space area, and we have to finalize, or we have to find that how many DC capacity we can achieve on that layouts, that area. So now it's up to you. You have to just fill out the overall area uh, with the solar panels. And what the DC capacity you achieve, you will proceed. So basically, the DC capacity we achieved from the nameplate of the PV module. Like the nameplates mean that if the solar panel has a nameplate of the 610 watt, so the total DC capacity, basically the number of the PV module installed in the solar plant multiply with the single PV module power. So this is called the DC capacity. It will be in the watt power, the maximum power, in the form of the kilowatt, in the form of the megawatt, in the form of gigawatt. It's up to the project's size. Now we move on to the second data, which is the AC capacity. The and the other one is the DC AC ratio. So AC capacity basically we have to give the two options. One is the inverter level, other one is the grid level. When we talk about the small level projects, we get this AC capacity at the inverter level because we don't have any grid connected with our solar power. But on the large scale project, we have to give the DC capacity at the grid level. Some of the clients will give us the clear instruction that you have to achieve the grid level AC capacity. How much? Like I I will give you the one example. Like in our projects, we are working on that, and the client has give us the instruction that we have to achieve the 63 megawatt AC capacity at the grid level when the power factor will 10% down or 10% up. Voltage fluctuations and the power factor fluctuation. We have to achieve the DC capacity, AC capacity, real active power. So for that, we have to compensate the war compensation through that. Uh, it is the different calculations. We have to calculate the war compensation requirement at that level. But I just giving you the overview of that. We have two options. One is the inverter level AC capacity, which is achieved by the nameplate of the AC inverters. Capacity like the inverter has a 300 kilowatt AC capacity. Multiply with the number of inverter installed in our solar power plant. It is called the inverter level AC capacity. And the other one is the level AC capacity, which I have discussed about already. Now, the third one option is the number of modules per string. Now we have to calculate its options. How many number of PV modules installed in one strings? We will connect the number of PV modules in one string in the series connection. It depends upon the environmental conditions of your site, the temperature, the irradiance, like that data, and the power and the. So I will now move on to the these slides. I just give these options. This is the calculations for the number of the strings per number of PV modules per string, minimum and maximum numbers. But minimum is the not is the major issue because it will mostly when we get the highest number of the PV module, mostly we will go to the highest number of the PV module connected in the one string. You have to check that because when your temperature is down in the like the winter times, your uh, panel when the temperature is down, your panel's output power output sorry output voltage will increase. When the panel voltage increase, the number of PV modules connected in the one string will multiply with the single PV module voltage, and the total voltage will increase. So that we will divide the total input power of the inverter divided by with the total power of the string. Sorry, total voltage of the string. So through that we will get the number of PV modules. But in the summer, the temperature will rise and the voltage will decrease. But in the winter, the voltage will decrease and the sorry, the temperature will be decreased and the voltage will be increased. Due to this increase, the number of the PV module, now this is the formula which we have to use to calculate the number of strings per number of PV module per string. It is as per the IC 62548 annexure F, in which they clearly given us that formula. Basically, we have to calculate these values like VOC of the PV modules. It is 48.09. Uh, the PV module, it is 610 watt Trina. V inverter maximum. So inverter has the maximum input voltage is 1500. VOC temperature coefficient. It is the VOC temperature coefficient which is available in the data sheets of the PV module. I will explain in the like the third week when we discuss the data sheets. I will explain all of you about that. T TDM BT. This is basically the temperature which is the minimum temperature at the site where we are installing our solar power plant. The minimum temperature will go there, and it temperature will be calculated through the solar GIS TMV file. It will be provided by our client us that we have to check that at the irradiance like 200 irradiance or 100 irradiance where the solar power plant generation is start. At that time the temperature is minus 1.6 degree centigrade. So this is the worst case, and I have selected this one. And the reference temperature is the standard test condition of the PV modules. Standard test condition basically is that the irradiance should be 1000 watt per meter square and the temperature should be 25 degrees centigrade. And so that's why the standard test condition is 25 degree. So what will we do? We divide, cause this minus 0.4 percentage per degree centigrade. So we have to um, convert this 0.4 uh, percentage into the value divided by 100, multiply with the VOC, because it is the in 1 degree change, like 1 degree change, the the VOC, the open circuit voltage of the PV module will be changed, because it will be this is the rate of the change per degree centigrade changes. So we have to check that what is the value of the beta V. So we have checked that the voltage per degree centigrade will be changed like that. And then we find the DT, delta T, T, T minus T standard test condition. So minus 1.6 minus 25 is become minus 26.6. And then we have this formula Ku is equal to 1 plus beta V multiply delta T divided by VOC. VOC this one 48.09. So what we have to 1 plus minus 0.6 multiply this one and divide this one, and we get that 1.06384. So uh, VOC cold, basically at the coldest temperature we have to multiply this Ku with the actual voltage of that PV module, and we get that it will become 51.61 1601 voltage. And then we divide the maximum input of voltage of the PV inverter with the string voltage. So we have divided this voltage, and we get that the number of PV modules will be 29 per string. So this is basically the worst case conditions, and we have to calculate. You can check that formula from the IC 62548 annexure F. It will be clearly given in that formula. In the previous version, like 2017, it will be somehow changed the formula, but now it will be changed again. So that's why you have to check again the latest revision of the this IC standard And if you have to find any IC standard, you can go to the doc 88, doc 88, doc 88. I will mention in the chat. You can check from that options. www.doc88.com. You can you can you can check this website. The IC standard will be available there. You can just read out these IC standards, not to download, not to use like the for the PDF, but you can check these values, these IC standard which you want. Uh, so so this is the formula for the string calculation. So when we have calculated this number of the string per PV modules and the DC capacity, then we move on to the mounting structure information. Basically, the mounting structure we have to give the mounting structures, like it will be the fixed tilt structure and it will be the tracker. Basically, tracker will be rotating with the direction of the sun, and the fixed tilt structure will be uh, in fixed directions. But when we talk the about the tracker, we have the two type of the tracker. One is called the single axis tracker. It will be rotating in the east west direction, only east west direction. You can mention about that. It will be only rotating in the east west direction, the single axis tracker. But the dual axis tracker will be rotating in the east west north south direction. In the fourth direction, it will rotate. So somehow the single axis tracker is more economical than, and it will be more used and simple structure. But the dual axis tracker, it will be complex one, uh, expensive one. They will uh, like increase the generation, the energy units, but their cost and other things are very more on higher side. That is why the single axis tracker, it will be mostly used in the large scale projects. But on the small scale project, the fixed tilt structure is used. We have the different types like uh, one PV module in the portrait direction, two PV modules connected in the portrait directions, two landscape PV module installed, three landscape L3 called. This is called the L3 three in the landscape. V2, V2 basically the vertical, and uh, V2 means two PV module in the vertical directions. So this is the mounting structure detail we get from the uh, client data, the ER requirements, or from the internal discussion with our company. If the client has given the clear instruction about the structure, we have to follow that requirement. But if they don't or give us the flexibility in that, we will discuss internal discussion with the higher management teams, and then we will decide what is the most economical solution for us, our solar power plant. Type type I have mentioned that, like the fixed tilt structure, they have the tilt angle, like this type of information. And the PV module information, PV module information, basically the size of the PV modules, the length, width, the thickness of the PV module, the power of the PV modules. These are the main two things required for the our solar layout formation. Then the pitch. Basically, the pitch, I will show you the screenshot. You can see that it will be the pitch from the lower front edge of the PV module structure to the back PV module structure, the front edge. Like you can see that it is called the pitch. You can just calculate from the center to center, front edge to front edge, back edge to back edge. Also, you can say that it will be pitch. You can see that in the top view direction, top view pitch distance. and this will be called the distance between the structure. Horizontal, it will be the clearance between the rows, and it will be the distance between the structures. You can see that in the horizontal direction, in the vertical direction. These are very important. You have to knowledge about that. And pitch, you know that. Now we move the structure edge to edge distance. Basically, it will be talk about this the distance, distance between the structure edge to edge. This is called the tilt angle. Basically, the tilt angle is the beta. What is the tilt angle at which we get the maximum energy numbers and the maximum number of the DC capacity we achieve? Because when we increase the distance, the tilt angle, if you increase the tilt angle, you should analyze that the back height of the structure will increase, and it will create a shadow on the back structures. So you have to increase the pitch of the PV module. So the DC capacity will be achieved on the lower side, but you get the energy number ratio on the higher side. But we have to give the optimal solution in which we get the energy number are on the best side, and also the DC capacity we will achieve. So the height above ground level. So it will be called like center this file where I have uh, rotating the mouse. It is called the axis height of the structure, and also the lower edge, like from the blue lower edge to the ground level. It is also called the the lower edge of uh, the minimum height. In the tracker structure, you have to give this axis height, but in the fixed tilt structure, you have to give the minimum height from the lower edge of the PV module to the ground. So it is called the height above the ground level. Horizontal distance between the PV module. Basically, when we are installing the solar power plant, you can see that they have somehow these white lines in the vertical and the horizontal. You can see that these are basically called the distance between the two PV modules. We have to define the the distance between the two PV module in the vertical direction, in the also in the horizontal direction. So this is called the distance between the PV module. You have to know about that. It is for the fixed in structure, it is around 20 mm structures, 20 distance. But for the tracker, it will be 26 like the 1 inch distance. So mostly it will be used as the 1 inch, like the 26 here, or 26 and then the side coordinate with the proper boundary. Because if you don't have any coordinate of the side and the proper boundary of the structure, there are the two options. One is that when we are installing the solar power plant on the rooftop, and we are conducting the survey, we will analyze and check the heights, the coordinates, the the shadow objects here on the buildings. We will analyze himself and make the layout. But like the remote area where I am working on the large scale project, which is basically installed in the South African region or in that country, and we are working in the Pakistan. We have no option of the survey. So what will we do? We communicate with the client. Um, Client will give us the exact KMZ file. Yesterday, I think one of student has asked about the KMZ file. Basically, you can see that it is the Google Earth Pro, and you can see that they have marked some boundary. You can see this one, like this is this is the boundary. They have like you can see that this uh, L, D, K, J. These are the, the corner of that boundary, and they give us the coordinate of that boundary. And also, this is the transmission line which is passing through that area. They have also given us the substation area. Also, they give us in the red line. You can see that they mark us that the access road entering to the PV facility. And this red line is basically existing road available there. A09, you can see that A104. This is basically the actual road available there, and you will get the access to this road to the PV module, PV plant, to uh, go the heavy trailers there to for the vehicle movement like there. So this is basically this is called the KMZ file. So you have to do that, export this KMZ file into the AutoCAD, and you will make the layout on the AutoCAD. And also you get the coordinate of the location, and you will put these coordinate in your SketchUp, and you will make the layout on the SketchUp. And this is also the KMZ file I have shown to all of you. Any no-go area, like here. This is basically the previous one, and we get the updated one. Like you can see that there are the multiple trees there in the field. You can see that from the Google Earth location. You can see that these are the trees available on that. And the client has marked that we have to leave these uh, trees there. You can we can't cut these we can't cut these trees. So we have to mark the area of these, and also the shadow of these structure these trees to uh, skip these locations for the PV module installation. So these are called the no-go area. Like they have marked the transmission line. We have to uh, skip this area and leave the empty space around these transmission line for the passing for this the tower locations. We can't uh, install the PV module in that location. And any object, shadow object, should be the proper height. Basically, in the ground mounted system and the roof mounted system, we have seen that number of buildings there around the PV area. In between the PV area, we have different like the you can say that the shading object there. So we have to analyze the height of that object, the width length of that object, and also we have to skip that location for the PV module installation. It is very important because in the future when the shadow is applying on the PV module, they will stop their generation, and client will definitely affect through that, and they will complain to you about that reasoning. And at the end, the designer will be affected for this issue. So this is called basically the overall layout formation we needed to calculate to make the layout. Now, from the tomorrow, we will make one layout on the SketchUp. Tomorrow we have to make the layout for the buildings. For the buildings, we will install one megawatt or 500 kilowatt solar power plant there, and we will make the structure of that uh, uh, like structure of the PV modules and the building's height. So now everyone should note down that you have to go onto the Google Earth locations, any random location. You can pick that. You will get the coordinate of that location, the buildings available there, assume their heights, the PV modules which we have to use. You have to get this data. I will share this the presentation in the group. You have to get this data. Everyone will individually uh, try and to get the data from the different Google Earth locations, somehow assumptions based, and we will discuss this first in the lecture tomorrow. And we will I will follow any of your assignments to carry out the layouts of the which we have to make on the SketchUp tomorrow for the building. So your task is to get the information of that data, and we will follow this data to make the layout, to export the DA file for the PV simulations, and we will follow the shadow analysis of the object there, and we will make the structure of the PV modules with the proper like the the garter and other equipment like that. We will make one by one, and we will make the class like the tomorrow class. It around I think um, 1.5 hours. But the issue is that I have I'm just informing all of you that I have the company like dinner uh, tomorrow at 6:30 p.m. Pakistan time, and most probably I will return back home at 9 p.m. or 9:30 p.m. and we will start our lecture after that. I will inform all of you in the group that when the class will start, like on the 10 p.m. or 10:30 p.m. Around that, the class will start. The tomorrow class will not start on the 9 p.m. So basically, our main project engineer there from the China in the in Pakistan. So we are giving the welcome party to them, and I have to participate in that dinner. Sorry, I'm just informing all of you that tomorrow class will be start late, but we will do the class um, by tomorrow. We don't skip the class, but we'll start late. So your task is to get this data like assumption based or actual data you have, because most of the people are experienced guys and they have like somehow the data they have. You will get this data and we will make the layout. Now I'm just sharing like stopping the screen, and you will raise one by one hand and ask questions. Yes, yes, Mudassir.
Assalamu alaikum. Sir, my question is that we just need to collect these coordinates, just only need to collect these coordinates, or we have to do anything with these coordinates? Like you have shared a file, maybe it was a Google Earth, maybe.
Yes, yes. Basically, you have to just collect like any factory area or any other area. There are the multiple buildings there. You have to just select that um, location there, because we have to make the layout for the buildings area. So you don't uh, like you don't uh, um, uh, you, I'm saying that you don't select the area where it will be ground. So you have to check the area where the buildings are available. Like in the Pakistan, there are the multiple factories there. You can check any of the factories on the Google Earth, and you will select that factory. We will make a just layout there, and we will make give the assumption based height the structure, because we have to give the knowledge and we have to practice that. and we will make the structures on that, and we will make this type of information. Okay. So for the Google for the buildings, we have only knowledge about the buildings, which to point out the buildings in the height of the buildings. But for the ground, we have to make this boundary, because in the ground level, if you don't have any boundary, you will like go outside of the boundary, which is um, available for the solar installation. Because in the large scale project, the government will allow different companies to install the solar power plant in the specific region, specific area. So that's why they will conduct the survey. The surveyor will mark the coordinate on the DMZ file and will send to the contractor for the installation of the solar power plant. So for the building, we just have knowledge about the coordinates. Any other question? Yes, Puram?
uh, thank you for that. Sir, my question is this, in small project, we can use, if I'm calling about ground mounted structure, we can use L2, L3, and L4. But if you move to a megawatt, like one or two, so mostly EPC company are using P2, P1. Uh, I'm confused about why they use the P1, P2 rather than L2 or L3 standard structure.
Basically, it's about cost implications. Uh, Basically, when we are installing these structures, the PV module in the formation of the vertical direction, uh, they somehow get the more number of the DC capacity rather than the landscape, but it will be cost effective. Not a major one issue, not a specific reason why they are using. It just availability of the structure, availability, the cost of the structures, and the formation of the area where we are installing, like the buildings, the ground mounted system. It will affect, because on the large scale project, landscape will not use, only the verticals.
So why we use the vertical? I'm just explaining one example. We have installed many projects in Czech Baba database or sector like that. So whereas we can use all of the type of structure like L2 and P1. If we use the L2, is somehow structure cost is on a high side, but in a vertical cost is lower side. But both of structures are producing the same productions of units.
I have already explained to you that not any specific reason for the installation of the structures, but only it will be the availability of the structure, because on the lower side, like the lower local levels, you have seen that they have selected the vendors. They have selected the vendor, and they have the different type of structure available there. Uh, like they have availability of the L2, L3 structure. They will purchase that and install that. But and also the main effect is the cost effective, because you should apply himself. You should apply himself and check that in the same area, if you install the vertical V2 or P2 structure, and you should also install the landscape options. Uh, for the P2 options, you will get the more DC capacity than L2 structures. So
Okay,
in the same area, you get the higher number of the DC capacity, means that you will get the more cost from the client side. You will get that. You will get the more number of energy number. So that is the main reason.
got it. Thank you.
Welcome. Any other? Yes, Mr. Seen Bhola. I think you have joined class yesterday late, and I have not seen your introduction. So you should introduce yourself the class. I think we will know all of about each other. Spuram, you have raised again the hand.
Yes, sir. I have another question about that. Okay, you can explain this higher if we DC capacity higher temperature, then voltage is lower, and when the temperature is lower, voltage is high.
Yes, yes. It is basically
Can
they
you more
are
explain
they
deeply?
are basically the temperature and voltage are the reciprocal of each other. When the temperature on the higher side, the voltage will decrease because the potential difference will decrease because movement of the electron will like which is created, it will decrease due to the because the main purpose and the main theory of that issue, I don't remember. Like in the study state, we have read about that, but I forgot about that. But these are like on the hand to mouth. You can see that it will be reciprocal of each other. When the temperature will go down, the voltage will increase, and if the temperature will go up, the voltage will. I got it.
Distortions are
I'm saying that basically the theory behind that the temperature rising, I forgot about because we have read in the study state study level. But the main one point is that they are reciprocal of each other. When the temperature is go up, voltage will down, and the temperature will go down, the voltage will increase. So in the winter level, the temperature will go down on uh, like 0 degree, 1, 2, 3, or lower than 0 degree. At that level, the voltage of the PV module will increase because because you have seen that the the standard test condition of the PV module are the 25. At that they
25.
get
Yes.
the 25. At that they
Yes,
get the
25.
maximum power. Yes, the maximum power. But when the temperature is go down and go up, they will affect through that. So when the temperature is go down, the voltage will increase. Voltage will increase. So they will affect the number of PV module connected in the series because we have to divide the input voltage of the PV inverter with the maximum input, maximum out open circuit voltage of the PV module. So you get the number of
DC
PV
output.
modules to that. You get that value. So when the voltage is go up in, at the lower temperature side, we have to give the margin there for the PV inverter to stabilize, to not to damage. In that case, they will capable of to withstand these voltage level. Okay.
Okay. Yes, if I see your formula VOC cold is equal to KU multiplied by VOC is equal to 1.0634. KU is mean.
Basically, it is the constant. Constant we get this basically KU. We have this is the multiplying factor. Basically, this is the multiplying factor we get from for the voltage increase, because we have the standard test condition open circuit voltage. When we apply the temperature factor, we get the Ku, the coefficient factor, and we multiply with the standard test condition of the voltage, and we get the higher number, higher value of the voltage, and divide that with the input voltage of the inverter. Basically, it is called the coefficient. You should check the IC standard, which I have mentioned, that 62548 NXCF. It will be like I think 2023 version. I think 2023 version. I think you can check from the website I have mentioned in the group, in the chat box. You can check that, and it will be very easy for everyone to read the IC standard. Anyone needed that standards.
These standards are mentioned on inverter side.
Sorry?
Inverter. These standards are mentioned on the inverter side or data sheet.
Basically, brother, that on the data sheets standard which are mentioned, basically these are the compliance by the manufacturer. But the inverter performance, their testing, and their different values, they will apply these standard. When you read out
So
these
what is the
standard,
mean
you
of
will
firmware?
see that.
Sorry.
Sorry?
One word is there. What is the mean of firmware? I have seen many times, listened many times, sorry. But I can't understand firmware. What is the mean of firmware?
From where?
Yes, sir, firmware. Is it software?
Sure. I think you should share this in this chat box. Sorry, in the group. I will see again, because at that time I don't remember anything
Okay.
about that.
Okay, continue.
Okay, for Mudassir.
Sir, Mr. Khorram is asking about firmware.
I think Puram.
Yes,
Puram.
that's right.
Firmware basically is the version of the software. You know, we have in our mobiles, we just see latest softwares with the passage of time. So this is what we can say firmware. Firmware basically the upgradation or type of software in the system. Like inverters have different type of firmware, 2.1, 2.22, 2.23, like that. So this is what the firmware is.
That's great. That's great, Mudassir. Thank you very much.
Got it.
Okay, okay, brother. Allah Hafiz. We will meet again. You have to follow this the assignment. You have to collect that data. Okay, brother.
Thank you.
Thank you. Allah
Inshallah,
Hafiz.
we'll got it and sure.
Okay,
Thank you
Allah
for
Hafiz.
all.